Hello and welcome to another math video. Today we're taking a look at our practice test for the second half of Chapter 2 in Algebra 2, beginning by solving some quadratic equations. Now here we're not giving you any kind of stipulations as far as how you solve these, but our basic choices are either factoring and using the zero product property or using the quadratic formula. And possibly even taking square roots of both sides if it is going to work. First thing we need to do here for number one is we need to get this equation so that it equals 0. So we would subtract the 3 from both sides. When we do that, we do get a 0 on the right side. This allows us to either factor or use the zero product property. In this case, you'll notice that x squared plus 6x minus 3 does not factor. So then we are using the quadratic formula. We would need our values of a, b, and c in order to know what to plug into that quadratic formula. And I'll write down the quadratic formula here just in case you're not familiar with that. Alright, so I have the quadratic formula there in red. Now a couple things about that quadratic formula. First of all, again, we have to make sure that we have the proper values for a, b, and c. Secondly, when I'm doing that quadratic formula, oftentimes I will square the b right when I plug that in to that b squared minus 4ac part of the quadratic formula, also known as the discriminant. So when we're looking at that b squared there, in this case b is 6, so I'll just go ahead and fill a 36 in there. Let's go ahead and get to actually using that quadratic formula. So we have x equals, this will be a negative 6 then, plus or minus the square root, and like I said, 6 squared is 36, minus 4 times 1 times negative 3. Extend this a little bit. 2 times a in this case will just be 2. So with the minus sign here, trouble there with the pen, and the minus sign here, that's really going to end up being plus 4 times 1 times 3. So that'll be 36 plus 12. So we're looking at the square root of 48. So we get that. And of course 48 is not a perfect square, but it does reduce down. So what we want to look for is we want to look for the largest perfect square that goes into 48. And so that would be 16. So the square root of 48 equals the square root of 16 times the square root of 3. So that is 4 square roots of 3. And again, I kind of just do that as a side note, because then when I actually go through writing that down, I don't have to copy all those other pieces down while I do that work. So we still have our negative 6. Now it's plus or minus 4 square roots of 3 over the 2. Now, because there are no i's, we only reduce as much as we can, but in this case we can reduce everything by a full factor of 2, which will get us to our most simplified form, which is really the only acceptable answer. So negative 3 plus or minus 2 square roots of 3, that's what we're looking at for our answer on that one. Alright. Moving on to question number 2. This one is already solved for 0. Again, you could look at trying to factor this one. However, this one is also not going to factor. So really, for what we've been doing, our one good choice then is the quadratic formula. There are no common factors or anything here that we need to worry about, so we just have a value of 4, a b value of 10, and a c value of negative 3. So plugging those into the quadratic formula, we get x equals the opposite of b plus or minus the square root. B squared would be 100. Minus 4 times a times c. Again, notice the minus in the negative, so that will end up being plus there. And our denominator is an 8 because of the 2 times 4. Let's see, 4 times 4 times 3, however you want to think about that, 16 times 3 or 12 times 4, it turns out to be 48. So we'd be looking at the negative 10 plus or minus the square root of 148 over 8, because we add the 48 and the 100 together. Now 148, again, not a perfect square, however, does have a perfect square factor of 4 that we can use to reduce that down. Let's see, so square root of 148, I'll just do this up here, so that's 4 times 37, so that ends up being 2 square roots of 37. And so when we simplify that, we get negative 10 plus or minus 2 square roots of 37 over 8. Now, we can't reduce by a full factor of 8. However, negative 10, 2 square roots of 37, and 8 all have a common factor of 2. So we can reduce by that factor of 2. So everything gets divided by 2. So negative 5 plus or minus, this will be 1 square root of 37. You could put the 1 down if you want, but we really don't need to. And then over 4. Again, it doesn't have an I in it, so we don't split that up any further than that, because that's as much as it reduces nicely. So that is our fully reduced answer that we have for that one. Alright, again, looking at number 3, we need to add that 25x to both sides. We need this quadratic to equal 0. So we add that 25x over. The 42 is already there. So the 3x squared plus 25x plus 42 equals 0. Now you might look at this one and try to figure, does this factor? And it actually does. You could still use the quadratic formula, but when you have some factoring that's going to work out, may as well use that. Again, so I'm looking at using a method where we focus on the factors of the x squared term and the factors of the constant term. Let's see, 4 and 5 don't work, but 6 and 7 sure do. Okay. Now, when the 42 is positive, that means those two numbers have to have the same sign. In this case, they do end up being positive because of the plus 25. And of course, the 3x squared is going to be positive 1 and positive 3. So we do know that it's going to be x and 3x because we don't have any other choices there. Again, assuming we know this works, which, again, you can figure that it does here. So now we need to figure how do we get the 25x. And the way that happens is, again, whatever is in this slot multiplies the 3x, and whatever is in this slot multiplies the x. And whatever we'll get x terms for those, and whatever those are, we add them together, and the total ends up being 25x. So if you're looking at like the 3, multiplying the 3 by the 42 is going to be obviously way too big, so you don't have to worry about that. Even the 3 times the 1 there, again, don't have to worry about doing that. It's going to be adding to the 42, so not going to happen. 3 times 21 doesn't work. Even 3 times 2 for 6 times 21, not going to work. 9 and 14, not going to work. 3 times 14, again, going to be way too big. So we end up looking here, 3 times 6 being 18, and then 7. So 18 and 7, that's the combination that we use there for that. Let's see, so the 3 is multiplying the 6, so the 6 goes here, and the x is multiplying the 7, so the 7 goes over here. And so that's what we get. So again, here, what I'm talking about there is that this is an 18x, and this is a 7x. Add those together, we get 25x. Of course, that's not really what we're doing. Of course, we are factoring, but we're factoring to get the solution to the equation, so then we have our factored form. And again, the reason this works is because of what we call the zero product property. It says that if x plus 6 times 3x plus 7 equals 0, that either x plus 6 equals 0 or 3x plus 7 equals 0, in a few cases both at the same time, but not in this one. So x is negative 6 and x is negative 7/3. Again, all I did there was subtract the 7 to get 3x equals negative 7 and then divide it by 3. And so there we go. Those are the two solutions we have for this one. X equals negative 6 and x equals negative 7/3. Here we go with number 4. I prefer having my x squared positive, so I would add that 4x squared to both sides. So I would have 4x squared minus 18x plus 20, and that will equal 0. Now, notice 4, 18, and 20 have a common factor of 2, so really what I'm going to do there is I'm going to divide by 2 just to get those values to be a bit smaller. So that will give us 2x squared minus 9x plus 10 equals 0. Now, again, looking at this one, it does actually factor. There's not that many combinations to look at, so it's a pretty good method to use. We know it has to be 1 and 2, if anything. And 10 doesn't have too many factors, just a couple pairs here, so 1 and 10, 2 and 5. Now it is a positive 10, but a negative 9, so both of these would be negative. And again, looking at the different multiplication combinations, 2 and 10 would be 20, that's going to be too much. 2 and 1 would be 2, and 10 is 12, so not, again, that doesn't work. 2 times 5 would be 10, and then 2 doesn't work. If we go 2 times negative 2 here, and 1 times negative 5, again, what we get there is negative 4, negative 5. That does give us the negative 9x that we're looking for. So that tells us how to split that up. And of course it equals 0. So I get an x and a 2x. Let's see, the 2 multiplies the minus 2. That means the minus 2 has to go here. And that would put the minus 5 over here. So those are the factors that we have. X minus 2, that one's simple enough. You set x minus 2 equal to 0, so adding the 2 tells us that x is 2. 2x minus 5, again, I can actually show you how this works this time. If we add the 5 to both sides and then divide by 2, we get x equals 5/2. So those are the two solutions to that quadratic equation that we come up with. All right, number 5. I would highly recommend doing something to make this a positive 2x squared. In this case, I'm just going to think of it as dividing by negative 1. So that will switch all of the signs there. So we have a 2x squared plus 5x minus 3 equals 0. All right, so again, looking at this one, it does factor, and again, not that many choices, so pretty good way to do that. It has to be a 1 and 2, if anything, and it has to be a 1 and a 3. Now, the 1 and the 3, it is a negative 3, so one of those is negative, the other is positive. Because the 5x is positive, I would at least guess that it's going to be a negative 1. And the thing is, if I guessed wrong, I'll get a negative 5x, and all I have to do is go back and switch the sign as far as which one's positive and negative to turn that negative 5x into a positive 5x. So really, it doesn't hurt to just throw that out there and see if it works. Again, not much for different ways that this could work out. So really what ends up happening is we have to multiply the 2 by the 3. That gives us 6. And then the 1 by the negative 1, which gives us negative 1 for our total of 5. So we know how that goes. And so we set up our two factors. One has to be an x, the other a 2x. Let's see, the 2 had to multiply the 3. I can see that up there. And then the minus 1 would go here. So there are the two factors. Again, we've been through this a couple times now. If we set x plus 3 equal to 0, we would subtract the 3 from both sides and get x equals negative 3. if we set 2x minus 1 equal to 0, maybe I'll show you this one anyway, we would add the 1 and then divide by 2. We found out that x equals 1/2. So those are the two solutions for that quadratic equation. Okay, number 6. Now, I know on every other one of these questions so far, I've wanted it to equal 0. This is the one case or one type of problem where I'm not going to want that. The difference being all I have here for x squared terms and x's at all is this single x squared here, or triple x squared, depending on what you want to think of it as. But all I've got is that x squared. So I can use a different method. I can just isolate that x squared and then square root both sides of the equation. That's going to be a much easier way than trying to factor or use the quadratic formula and really make this process a lot faster. So in order to keep that process going, I'll stop talking about it and actually do it. In order to get that x squared by itself, I just have to divide by 3. 21 divided by 3 is 7. And then I square root both sides now. Square rooting both sides. Sometimes people forget. When we square root both sides, we have to include a plus minus. Again, what's happening there is, of course 7 is kind of weird to think of because it doesn't square root evenly. But what's happening there is when we're squaring x, whether x is positive or negative, the result is going to be positive. So we need to say that it could be either positive square root of 7 or negative square root of 7. Because again, whichever one of those you square, the result is 7. And so again, this is actually two answers, square root of 7 and negative square root of 7. So just like our other quadratics, we get our two answers for that one. Alright, now looking at number 7, we've got our x squared and our x. We don't have a constant term, so traditional factoring method is going to be kind of weird here. Quadratic formula going to be kind of weird here. So what I would look at actually is, might say, hey, there's a common factor there. There's actually a full common factor of 5x. I could factor the 5x out. I could also go ahead and just divide, well, that looks funny, divide both sides by 5, just to make those a bit smaller. That would give me x squared, try that again, x squared minus 2x equals 0. Now, again, what nice thing about that is that then my numbers are a bit smaller, easier to deal with. From there, I would actually go ahead and factor the x out. Again, what I'm doing is rewriting that as x times x minus 2. Again, that way I get my factors. So again, it's not a traditional factoring approach, it's just taking out a common factor. So again, we always need to be looking for those common factors. Very often people forget to do that, so make sure you're always thinking factoring out common factors. So x equals 0 from the just plain x factor, so that one's actually done. And we set the x minus 2 equal to 0 as well. I'm having trouble with my pen here, but let's see if we get that to work. So x minus 2 equals 0. Add the 2 to both sides, we get x equals 2. So again, those are our two solutions that we have. X equals 0, x equals 2, what we're looking at there. Alright, finally on to page 2. We're trying to square root negative 144, and we're going to simplify that using the imaginary unit I. And again, we've moved past the idea of just saying that there are no real solutions here to dealing with the imaginary numbers. So that would be the square root of 144, I. And then square root of 144 is actually a whole number. We get 12 when we square root 144. So that's actually 12i. Moving on to number 9, we are simplifying this expression. Now, as far as like adding and subtracting complex numbers go, we really just do the same thing we would if I were a variable. So in this case, to just show you everything we're really going to do, we're going to go 1 plus the negative 4. So I'm actually just going to go minus 4 because plus the negative is the same as minus. And then a plus 6i and a plus 2i. So again, I can put my normal numbers together. That's going to give me a minus 3 or negative 3. And then adding the i's together will give us an 8i. And there we go, negative 3 plus 8i. Again, make sure you are always writing the answers for complex numbers in that pattern a plus b times I. That's just accepted notation for that. Okay, let's throw that answer in a box, make it obvious. Now subtraction. Now I know sometimes people struggle with subtraction. Be very careful with this. You would hate to add when you're supposed to subtract or vice versa. So we have our 2. We're subtracting a 3, so minus 3. We have a minus 5i, and we're subtracting a 4i, so really just minus the 4i. From there, 2 minus 3 is negative 1. And minus 5i minus 4i, we're looking at minus 9i for that. You can put that in a box, that's the answer. Oh boy, now getting to number 11. So here we want to write this in that complex number form, the a plus bi. The difficult thing is we got a 4 minus I in the denominator. So what we need to do is we actually don't really do any division whatsoever. We just multiply by the complex conjugate of the denominator. Now, when I say multiply by that, I really mean multiply numerator and denominator both by that. Again, the reason that we can do that is because 4 plus I over 4 plus I is really just a funky way of saying a 1. And if we multiply something by 1, we don't change its value. Now, again, here's my first chance on this video to use what I call the box in order to find my product for my numerator there. Some people like to FOIL, which works well here also, especially though you throw in the complex numbers. I think the box does a nice job of showing us all this stuff so we can keep track of all those little details just that much easier than we can with foiling. It's pretty simple. It's just really an area model for the multiplication and does really the same thing the FOIL does. It reminds us we need to find 4 products. And so like in this top left cell, we multiply the negative 1 and the 4 together, then we multiply the negative 1 and the I together, and then we multiply the 3i and the 4 together, and then we have a 3i squared. Now I write this kind of small up here because if you remember, I squared is really negative 1. If you don't believe me, check on your calculator. So then 3i squared would really be negative 3. And so that negative 4 and negative 3 will combine to be a negative 7. And then we have a 12i and a minus I, so that's going to be plus 11i. Now the denominator's the fun part. If you know the pattern, it is very slick. The way the pattern works, if you have an a minus bi, like we do, times an a plus bi, like we do, the result is really just a squared plus b squared. Again, you could box or FOIL that out as well, but man, knowing that pattern makes this so easy. We square the 4, we get 16. We square 1, we get 1. So that's really 17. Now I'm going to go ahead and do 2 things at once here. I'm going to split this up. So negative 7 over 17 plus 11 over 17i. Again, very much in that form a plus the bi. So a being the negative 7/17 and b being the 11/17 for that one. And of course then the I at the end. Now comparing that to number 12. So in 11 we had 4 minus I in the denominator. We had to use the full complex conjugate 4 plus I to cancel out those complex numbers in the denominator. Number 12 though, we just have that little 6i there. Now here you could use the complex conjugate, which would be negative 6i, but we can also get away with a bit of a shortcut. Since it is just a plain old lonely 6i there, all we have to do is multiply by I over I. That'll turn our denominator into 6i, that's funny I, 6i squared. And so again, remember I squared is negative 1, so that's really a negative 6. And then the numerator, just a little bit easier as well. Really I'm distributing that I into that numerator. So I will have a 2i, I'll put that last here, and then a negative 5i squared, and that's positive 2i, so plus that. Of course, again, the I squared is a negative 1, so negative 5i squared would be a positive 5 plus the 2i. It is a complex number, so I have to split that up. So negative 5/6. Now, minus, because the negative on the 6. 2 over 6 would reduce down, so that'll be 1/3 I. And again, make sure you're always reducing these down. That'd be bad to not reduce a fraction. So that's what we're looking at there. All right, number 13. I'm going to slide over here in the screen so you can see the rest of the directions. It says use the quadratic formula to find the solutions. Write your answer in the form a plus bi. Again, I suppose we could be trying to trick you there, but we're really telling you ahead of time that the answer will be a complex number. So you can expect that to happen. Now this is kind of a strange value of a, and you could actually work with the one. So you could actually work with that 1/2 for a. Personally, I don't really want to. It works out okay though, just because it's a half. But for other situations too, if you have another fraction that's not going to work out as well, like a third or a seventh or whatever it might be, what I would do is go ahead and, in this case, multiply the whole equation by 2. And again, I can do that because I can multiply the right side by 2, which, being as that's 0, I don't really need to do anything with that because it's still just 0. It does increase the size of my other terms slightly, however, worth it, I think, to get rid of the fraction. And again, like I said, this one actually works out pretty well with the fraction just because of the different things we do with I, but I'd rather just avoid that. Let's see, it does tell me to use the quadratic formula, so we're just going to go ahead and get into that. So a is 1, b is negative 2, c is 10. So we plug that in, and we get started. So x equals the opposite of b, which will be 2 plus or minus the square root of b squared, which would be a positive 4. Now, again, that's probably one of the number one things people do wrong here is they get a negative 4. So don't do that. You square a negative, it's a positive. Minus 4 times a times c all over 2a, so that'll be a 2. Again, so notice all the things we're doing to a, it ends up getting doubled or multiplied by 4, so that's why the half would have been okay. But still, just kind of easier not to have to worry about that. Let's see, now this ends up equaling, if I can get this to write nicely, let's see, this ends up being 4 minus 40. So that's actually going to give us a negative 36 over 2. Now at the top of this page we simplified the square root of negative 144, and that was a 12i. So same kind of thing here. The square root of negative 36 is a 6i, and that's over the 2. Again, it has an I, so we have to split it up anyway, but this actually works out just fine. We get 2 over 2, which is 1, and 6 over 2, which is 3. So 1 plus or minus 3i for that one. And again, that is 2 answers. All right, we're getting close. We're down to the last 4 questions. Starting with number 14, we need to solve and graph the quadratic inequalities. So really what I'm going to do is more or less think of this as an equation, looking at x squared minus 16 equals 0. By solving the equation, and that looks funny, but okay, solving the equation is going to give me the boundary points for the inequality. Now in this x squared minus 16, man, this is my favorite factoring pattern, not like this single one, but just the whole idea in general. That's that difference of two squares pattern. So that factors as x plus 4, x minus 4. It's one of those things, if you can't recognize that, you are going to struggle, because this thing comes up all the time, and it, even though you can use the regular factoring methods, that just messes with people's heads. So recognizing that pattern, again, what you need to fit that pattern is you need a perfect square here, x squared, is a perfect square, and a perfect square here, 16, that's a perfect square, and you need the difference of those two things. So x squared minus 16 fits that, and then to figure out the factoring, you just square root each piece. So square root of x squared is x, square root of 16 is 4, and we do a plus 4 and a minus 4, so we get the minus 16. What happens there, the reason we don't have an x term is because we get a 4x and a minus 4x. Those cancel out. Anyway, so really important that you know that factoring pattern. And we get our two factors. We get x equals -4, x equals a positive 4. And again, we get that from setting those equal to 0 and then solving. So, but those are the 2 points. Now, again, like I said, that actually gives me the points on the number line that are going to be the boundary for my inequality. And I'm just going to throw out a number line here. It doesn't have to be too fancy or anything. But of course mine looks great. So we've got, now we don't have an equal to on the inequality. That means we're going to have open circles. And of course one of my advantages here is that I can change colors, and these are quite the open circles there, but there we go. Open circles. Now the real question is, and it has to be one of these two things. It has to be one of these two. Real question is it the area in between -4 and 4 that makes that inequality true? Or is it the area outside of those inequalities that makes the inequality true? And that's just kind of fun because then you get to have dual lightsabers and whatnot. Now there's two ways you can do that. You can be like me and just think of having a phantom parabola, which it's not that easy with the marker here, so maybe I'll just use the highlighter. So this parabola has a positive a value. Ooh, that's a big highlighter. All right, let me change that quick. I don't want the highlighter that big. So the phantom parabola that's not really there would look something like this. And so I can see that then it's between those two where the x squared minus 16 would be less than 0. Now the issue is I want to see where it's greater than 0, and that's where the inequality is up here and up here. So that's outside of the -4 and 4. So actually maybe I'll even just use that highlighter to show where those go. So that would be where we graph that. So that would be the graph part of the inequality. And then I need to write the solution. And again, the parabola not really part of the solution. It just helps me see what's going on. The other way we can figure this out is we can use a test point. Now you can use any test point. I would recommend 0. It tends to work out pretty well, largely because when you plug 0 into x squared minus 16, you just get a -16. So let's see, so when you plug that in, you get -16. That is less than 0, and we want greater than 0, so that would tell you that this is the false area. False, as in not true, and so then inside is false means outside is true. Again, it has to be one of those two things for these. So we need to write the inequality though. Okay, so let's keep moving here. So x has to either be less than -4, or, again the or is important, or x has to be greater than 4. So what we're saying there with that solution is we're really painting a picture of what values are going to make that inequality true. And again, going all the way back to that original inequality, x squared minus 16 is greater than 0. So what we're saying here, pick a number less than -4. Like -5, -6, -7. Plug it in here. That's going to make it true. Pick a number greater than 4. Plug it in here. That's going to make it true. So again, we're just saying that's the solution. So again, what we're looking for here, we don't need all of this extra stuff down here, but we do need our solution, written as a compound inequality in this case, and we do need the graph. Okay, we don't need the purple parabola. We don't need the -16, we don't need the false, okay, but we do need the graph and the solution written out. Okay, moving on to number 5, looking at, or not 5, number 15. Thank God we're not on number 5. Same sort of thing, except now it's a little bit more of a full-fledged problem than just the x squared minus 16. So we got that x squared minus 3x minus 10. Now, of course, the quadratic formula would work here, but this one does factor as well, so it'd have to be a 1 and a 1, and either 1 and 10, or 2 and 5, and again, it's a -10, so one of the numbers has to be negative. I would guess the larger of the two, since it is a -5, and in this case it's not too tough, because it's got to be the 2 and -5 with the 1 and 1, so again, looking at that, and again, I'm going to think of it as an equation. And because the x's are the same, it does not really make a difference where I put the 2 and the 5. And hopefully you can look at that product of binomials and see that that would give you x squared minus 3x minus 10. All right, so the solution from here, for our equation, which again is really just going to give us our boundary to our inequality, is -2 and +5. All right, so that gives us our number line, gives us an idea what that looks like. So if I put 0 in the middle, -2 over here, +5 over there. Ooh, this one does have the equal to, see that there? So when I put my points on here, I will fill them in. Oh, I don't like coloring things in with this marker. Let me see. Oh, hey, look, a little spiral pattern. That works pretty well. Same sort of thing here. There we go. Okay. Again, same question as before. Is it inside or outside? Phantom parabola tells us, since it has a positive x squared, come on, positive x squared shows us this. So it's in between the 2 points where the parabola would be less than 0. Again, the positive negativeness of the parabola is directly a result of positive or negative value of x squared minus 3x minus 10. And again, I know it goes up like this rather than down because it's a 1x squared rather than a negative 1x squared. We are looking for when it is less than or equal to 0. So that would be the area that we would actually shade. Maybe let me pick a different color here. It's different than my parabola here. Come on. There we go. Got it. All right. So we'd connect those two. Again, showing that those values from -2 to +5 are the ones that are going to solve that inequality. We do need a written solution. Now, when it's the area between 2 points like that, we can write that as a 3-part inequality. -2 has to be less than or equal to x, which also has to be less than or equal to 5. Again, we cannot do that with the previous one where they're the 2 areas going away from each other. It just doesn't work. I'm not going to get into why right now, but it just doesn't. You could write this as 2 separate inequalities. X is greater than or equal to -2, and x is less than or equal to 5. In that case, again, the and is just as important as the or was earlier, which is to say vary. All right, so that's those. Boy, okay, last 2 questions. Solving a system of equations. Here we go. So, different ways you could do this. We're going to use substitution, though. So I'm going to take the 5x minus 7. And since that's what y equals, I'm going to go over here and I'm going to say, well, instead of y, I'm going to have 5x minus 7. So I get 5x minus 7 equals 2x squared minus 5x plus 1. And I want everything on the same side. So I like the 2x squared being positive. So I'm going to subtract that 5x. And since I'm busy doing that, I'm going to go ahead and add the 7 at the same time. So subtracting 5x, adding 7. All right, here we go, new color. 0 equals 2x squared minus 10x plus 7. All right, we don't have any common factors to worry about here. Let me see. We would expect these to factor because we kind of expect them to be nice answers, just because it'd be kind of rude if it wasn't. You know, you get a bad x value, you get an even worse y value. So looking at that, 1 and 2. Why did I put a 7 there? You guys should have told me that's supposed to be an 8. I'll fix that. There we go. That's an 8 now. 1 and 8, 2 and 4. Just making sure you guys are paying attention, that's all. Okay, now it's a positive 8, but a negative 10. That means these are both negative. So negative, negative. All right, so doubling one of them because of the 2, the other one stays the same. So I'm not going to double 8. That would give me 16 in 1. Not going to work. 2 and 8. Hey, look, I think I found it. Oh, wait a second. Oh, man. Okay. I didn't even see that. Oh, because I had the 7 before. Yeah, notice that I had the 7 before, so I said no common factor. Well, when it's an 8, there's a common factor. Let me see, where did this one go? Here it is. There we go. Okay, so I'm going to... Oh, no, my eraser doesn't work. Okay, so I'm going to take and divide everything by 2. Divide by 2. Make this easier. This also gets divided by 2, but it's still 0. Okay, so x squared minus 5x plus 4. Okay, yeah, I could tell. Okay, anyway, sorry. Okay, this will be easier anyway. 1 and 1, 1 and 4, 2 and 2, and again both negative because of the positive 4 and negative 5. So we know it has to be x and x. In order for it to be minus 5, it's going to be minus 1 and minus 4. So that tells us, I'm going to come up here, x equals 1, and this equals 0, and x equals 4. Now once I know that, I can go back to either of these two original equations and plug the 1 and the 4 in to find their corresponding values of x, or y, I mean. I would use the second one. It's just going to be easier. It doesn't hurt to check in both, but a good idea to at least start with the easier one. So it's either 5 times the 1 minus the 7. So 5 minus 7, that would give us a negative 2. So 1 negative 2, that's a negative sign, would be one of the 2 halves of this answer. And again, each answer will be in ordered pair. We need to keep those paired up. Alright, the 4 would be the same kind of thing. 5 times a 4 minus a 7. So 20 minus 7, so we get 13. So that ordered pair would be 4, 13. Now you could check this by plugging the 4 back into the first equation, the one we didn't use before. Plug the 1 back into the first equation, the same one we didn't use before. If you didn't get negative 2 and 13 for those same spots, then that would tell you that you did something wrong somewhere at some point in time. Relating to this math problem. But in this case, I've already done that, so I double checked it already, and unlike earlier, that part was mistake-free, at least the answer was. Alright, last question. Okay, same sort of thing. We're going to use substitution. I'll take this, plug it in here. So I get x squared minus 3x minus 4 equals negative x squared plus x plus 2. Since we want the x squared to be positive, we really do, I'm going to add the x squared, and since I'm adding, I'm going to subtract the x and subtract the 2. So I got to do that over here as well. Add x squared, subtract x, subtract 2. Alright, let's see, we get 2x squared minus 4x minus 6 equals 0. Ooh, we see that common factor of 2 right away, so we deal with that. You could factor it out, but since I have an equation, I'm going to divide by that instead. X squared minus 2x minus 3 equals 0. And then this turns out to be a pretty straightforward factoring question. 1 and 1, 1 and 3, where one of them is negative. So it has to be x, and of course this equals 0. And since it's x and x, it does not matter where we put each of those, but hopefully you can take a look at that product and see how it does give us x squared minus 2x minus 3. And so that leads us to x equals negative 1 and x equals positive 3. Again, I'll come back up here. And x equals negative 1, x equals positive 3. Okay, now, I don't really have a better choice. Well, I guess I like the second one better. If I plug that negative 1 in there, let's see if I have enough, give myself enough room here. Y equals, now if I square negative 1, I get a positive 1. 3 times the negative 1 would be negative 3, but I already have a minus there, so it would be plus 3, and then minus 4. Hey, look at that, that turns out to be 0. So negative 1, 0 appears to be one of the solutions. And if I do the same kind of thing with the 3, square 3, you get 9. Minus 3 times the 3, so minus 9 minus 4. And look at that, the 9's cancel. We get a negative 4. So 3, negative 4. Alright, there we go. Those two solutions. Again, probably worth your time to double check that in the other equation. Make sure that you do get negative 1, 0. You do get 3, negative 4. I did that earlier, and this has already been like one of the longest videos of all time. So, thank you very much for watching, and hopefully you found this to be extremely helpful.